Okay, welcome everybody. It's the Konflux community call. It's January 29th. We've got a couple points on the agenda. Gal, I think you're up first with Tecton and Q.
Yeah. Okay. Hi, everyone. So for a few months, the integration with Q, for those who don't know, Q is a controller for Kubernetes that enable Kubernetes it adds queuing capabilities to Kubernetes, which is really, really useful when you use a cluster. Yeah, it's Q with K. When you use a cluster for running batch workloads. So usually in Kubernetes, you have deployments, you run your servers, you maybe run cron jobs. The workloads in the cluster are not very dynamic. When it comes to clusters that run batch workloads, I'm saying batch because, for example, in Konflux, those are pipelines, but for other use cases, it can be just plain Kubernetes jobs. For AI, ML, can be other frameworks that knows how to build, train, test models, and then they use their own kind of jobs. They have their own abstraction to run jobs on Kubernetes. Now, when you need to run those kind of workloads, it turns out that the cluster is not a good fit for it. And the queuing that it has, like the built-in queuing, maybe it cannot call it a built-in queuing. Like just the scheduler the cluster provides is not enough for handling batch jobs. So queue was invented. It adds queuing capabilities to Kubernetes, and for several months there is a plugin called Tecton Queue, which is now proposed to the Tecton community, which allows to use queue with Tecton. And the way that it works is that on a cluster, you can define a queue with certain resources. The simplest configuration is, for example, the amount of pipelines that you allow to run concurrently. And when a pipeline is getting created in the cluster, there is a mutating webhook that creates the pipeline with a status of pending. It means that the resource is created in etcd, but the pipeline's controller is not starting it. Tasks are not getting created, resolution requests are not getting created, pods are not getting created. So the actual workload, the actual load on the cluster is not applied yet. And then Q and Tecton Q do the calculations of, do we have room to run this pipeline? Yes, no, do we need to wait? If there is room, they take the pipeline run out of the queue and change the status, remove the pending status, and this is how the pipeline starts to run. And from there, everything continues to work as we all know, except for that now that the running pipeline uses it uses the quota, right? It consumes part of the quota that we defined that can be used for that particular queue that the pipeline is belong to. It's pretty neat, very, very useful. But what do you do when when you don't have enough capacity in your cluster? Like after you add queuing, you figure out what is the capacity of your cluster. You understand how many. I'll keep it. I'll speak about our use case. How many, for example, pipeline runs you can run in your cluster based on no, it depends on the actual definition of the pipeline run and the usage patterns. But there is some kind of a pattern that you can discover, and you can say, for example, I understand that to be on the safe side, I can run at most 300 pipeline runs concurrently. More than that, the pipeline run should wait in the queue. Now, how can we improve? And for that, queue offers the feature which is called multi-kueue. Okay, let me share my screen. Up until now, it was just an introduction about queue, which is needed to understand the multi-kueue feature. So what is the problem? We have pipeline runs that are waiting in the queue. There is no more room to run them on the cluster. Queue has a built-in feature called multi-kueue, which allows to offload jobs, so any job, to a remote cluster. And this offloading also participates in queuing. Means that those minion clusters that you can offload jobs to, in our case pipeline runs, they also have queues defined on them with the amount of resources that they can consume from the cluster. And based on the availability of resources in any of those minions, or as we call them in this drawing, spokes, based on that, one of them is getting chosen and starts to execute the pipeline run. How does it work? Pipeline runs are getting submitted to the hub. The pipeline's controller is not going to process them. They are created in the pending state, as I've explained. And based on the queue configurations, if the queue is configured in a way that allows queue to dispatch the workloads to remote clusters, then queue creates a resource called workload. This is like an internal representation of canonical representation of a job that queue is using internally. Creates the workload on all of the spoke clusters that are candidates for running the workload. The first one of them that admits the workload is the one that will own it and will run it, and then queue from the hub will delete the workloads from the rest of the spokes, and then the workload pipeline will start to run. From there, queue will make sure to copy the status field of the pipeline run from the spoke back to the hub. So we can see the status of the pipeline run on the hub. Now, what is the advantage over here? We have on the hub just the pipeline run resource. On the spoke, we have the pipeline run, but also all of the overhead. So task runs, pods, events, resolution requests, all of those things that makes the cluster under load, all of those are being created on the spoke. So the pipeline is expanded only on the spoke. And we get back the status by syncing it. So not everything in sync is being synced back, just the status. Now there are so okay, that's great. We are able to run the pipeline remotely and get the status, but how do I see logs? How do I sync secrets? So this is like a very initial implementation. There is more to invest in it to make it production grade. But for the initial implementation, there is a service that only syncs the pipelines as code secret, which is created for accessing the, for example, GitHub. It's a short-lived token that is created so the pipeline can access GitHub. So this is something, the only secret that is getting copied. In general, we don't believe that we should copy any secret because then you can lose track of them and like it's not very secure. I can speak later about how this can be solved using workload identity, for example. Another thing for watching logs, there is this results proxy server that will allow to stream logs from the spokes cluster. So as usual, you can connect to the, as a user, you are not aware of the spoke. So everything you do you do with the hub. You connect to the hub, you want to see the logs, no problem. There is a proxy that will identify that the pipeline runs on the spoke and will channel your request to the spoke and stream the logs back to the hub. Logs are getting collected to Tecton results. Tecton chains right now is out of scope. There is some things that should be solved in order to integrate it into this solution, but it will be done. And if I didn't mention, a pipeline's code runs on the hub, and this is like where the endpoint which receives webhooks exists. So this multi-cluster solution, the problem that it solves is scaling horizontally. Let's call it like horizontal cluster scale. So you can run workloads on more clusters. But it doesn't solve high availability, for example. It's not like you have, you still have a single pipeline as code endpoint that should receive the webhook requests and create the pipeline run on the hub cluster. Questions?
I have a question. How do we plan to handle mounted resources by user? For example, secrets.
Okay, it's a great question. I have a great answer. This is why. So, as I mentioned, we don't want to copy secrets around. The plan, and it relies on something which is called workload identity. The plan is that imagine that you can start a pod, and the pod gets a secret that identifies it. And using this secret, it can fetch other secrets. It can access a vault, for example. Now, if you can get into a point that it doesn't matter where this pod starts, it doesn't matter in which spoke, but it gets an identity that allows it to access the central storage for secrets, then you don't need to copy secrets around. The pod starts, it gets from the environment an identity that it can use to fetch the secrets that it needs. So, for example, let's say that I have a namespace called gal in the spoke. Let me use let's use something simpler, like a simple approach for workload identity, which is based on service accounts in Kubernetes. I can say that if I have a certain service account for a certain namespace in one of those clusters, it has access to a certain location in Vault, a certain directory in Vault. And then it doesn't matter like in which spoke the pod is landing, it can fetch secrets. Give you another example. Kueue, okay, relevant for image controller. Today, there is a robot account for each repository, right? And then we have a static secret. Kueue supports OIDC federation. What does it mean? It means that you can configure your organization in Kueue to recognize OIDC tokens issued by your issuer, the issuer in your environment. And using those tokens, you can get access, you can get a short-lived token for accessing for robot accounts. Okay? It means that you don't need a static token anymore for pushing an image to Kueue. You just trade your identity for a short-lived token, and then you use this short-lived token to push the image. So there are two approaches where we can use OIDC federation to exchange token for an access. This is the preferred way. For those services that doesn't support it and we still need to fetch a static secret, we need the idea is to use workload identity to fetch this static secret to the pod wherever it is going to run in the fleet. questions about this one. It's not simple, but yeah, that's the future.
I guess I've got a related question, which is that like today the secret, Kubernetes secret, is like an abstraction between the payload of our tasks and the external secrets operator and the remote secret storage. So you could use Vault, you could use AWS Secrets Manager. External secrets operator handles those differences and makes whatever the content was available as a Kubernetes secret, which then the pods use, as our tasks use, as a kind of simple way of accessing any secret. Doesn't matter where it came from originally. In this design, does it become incumbent on the implementation of the task payloads to know how to speak directly to, like, say, a Vault API, HashiCorp Vault, or to AWS Secrets Manager?
Not necessarily, because, for example, with Vault, a sidecar can be used. So like a sidecar can be injected by a mutating webhook to the pod, and then it knows how to handle the secret fetching.
Okay.
That's the idea. I cannot say that I ever tried it, but from reading about it, and that's one of the approaches. Yes.
That's reasonable. I don't see exactly how it would work, but that's a reasonable thing to try. Can I ask 2 more questions? One is just for clarity about the minion clusters, spoke clusters. Let's say on the hub cluster, there's a Gal namespace, a Mikola namespace, and a Ralph namespace. Are there all 3 of those namespaces on each of the minions, or do they run in like synthetic workspaces that are like provisioned for individual pipeline runs?
No, there should be a namespace with the same name on the spoke. It's like a mirror namespace. With also queue configurations on each spoke.
Okay, thank you.
So a local queue, cluster queue. Yeah.
My last question is about the results proxy server. The name results is throwing me and making me think about Tekton results. Is it more of a Tekton community-based component, or is it more of a queue community-based component? You know, is it generic to queue and other executors, or is it a Tekton-oriented proxy?
It is Tekton specific. I can share the implementation. In chat. Tekton specific. Maybe there is a place for something more generic, but for now, yeah.
And in general, the Syncer service, is it a Tekton specific implementation, or is it a queue community component?
No, it's specific to Tekton, and its sole purpose is to copy the pipelines as code secret.
Okay.
This short-lived, it's like short-lived auto-generated token that Pack generates on the hub, and in order to get something usable, at least for MVP, we needed to get the secret into the spokes. That was like the minimum thing, and we don't want to extend it to replicate anything else.
Okay, thank you.
Yes, who's next? Tim?
When the hub sends the pipeline run to each of the minions, what's the mechanism that makes sure only one of them progresses?
It doesn't send the pipeline run in advance. So the way that queue works is that there is a resource called workload. This is what queue actually reconciles. Now, I've mentioned Tekton Queue, which is the plugin that creates a workload for pipeline runs. And then, so it does 2 things. It creates a workload for a pipeline run, and it also, based on changes to the workload, it propagates them to the pipeline run. In a single cluster setup, the way that it works is that the pipeline run is getting created, and then Tekton Queue reacts to this and creates the workload. In a multi-cluster setup, there is something which is called pre-built workload. So what does it mean? On the hub, as usual, the pipeline run is getting created, and then a workload is getting created. And then on the spoke, a workload, which is called a pre-built workload, is getting created. Why does it call pre-built? Because it is created before the pipeline run. So as opposed to a single cluster setup, here we first create the workload. Now, Q takes this workload and tries to admit it. What is admission? It tries to find room for it. Like if there are enough resources in the queue, we'll admit it. It means that you have the green light. You can go ahead and start the workload that is being abstracted. Q on the hub watches all of those pre-built workloads, and the first one that is admitted is the one that wins and gets the opportunity to run the pipeline. So let's say that the pre-built workload was created on all three spokes. This spoke on the right admitted it first. It is going to be the only one that will actually where the pipeline will be actually created. Okay, that's the
pre-build workload is the arbiter. The hub then makes the decision on who was first and then creates only one workload for the real pipeline run on whichever spoke one.
It's like, if I remember correctly, it's like the pre-built workload. It is going to. It's not like a new workload is getting created. It's the pre-built workload is there, and then the pipeline is getting created. Now it's not a pre-built workload anymore because you have a workload and a pipeline on the same cluster, and the pre-built workload is getting deleted from all of the others. So it's not like the hub decides where the pipeline will run. It sends to all of the candidates. This is the pipeline I want to. This is a workload I want to run. The first one that says I can take it is the one that wins and will actually run the pipeline. Yes. You're on mute.
You're on mute.
It seems possible that the hub could send the workload to all three spokes, and then before it has a chance to run its reconcile loop, two of the spokes could say, I got it, and mark their workloads as admitted. And then I guess I suppose it's the hub's responsibility to like look at all the ones who have said yes so far and then just choose one and delete the workloads from the other spokes.
I can send you there are fine details indeed in this in this flow. Luckily, everything is deployed upstream on queue. So if you want to have deeper, if you want to have deeper understanding, I shared the link in chat. This is the upstream queue documentation. You can go over here and it explains exactly the flow that I've just explained. Now, the nice thing about this is that you won't see any mention about Tecton or plain Kubernetes jobs over here. Like the flow is the same for any kind of job, so it's pretty amazing. See, it supports all of those kind of jobs. We are using, this is something that was actually added by someone from the Tecton community to support external frameworks. And this is what we are doing in Tecton. We are using an external framework. Yes, Mikola?
Yeah, so I would like to have a bit more clarification on the logs. So will we have some real-time streaming, or how I can, for example, watch a task run as a user or a developer and see logs in real time? Should I like search for the spoke, or it would be possible in the hub?
From the hub.
Okay, good. Thanks.
This is the this is why this proxy server is needed. So you issue a request to see the logs. You know, the usual REST endpoint for see the logs for a certain task run, and then it knows to forward the request to the correct spoke cluster. This is why it is needed.
Okay, and So the plan is to make it optional to install, or is it just an idea? So do we plan to integrate it into the installer, or what's the further plan to deliver it?
It is going to, so right now, no changes to Konflux. I'm showing it for awareness. We don't need to do anything on our side. This is going to be included in Tecton. The operator is going to deploy, the Tecton operator is being changed to deploy the additional services, and in a multi-cluster setup, not all Tecton services should be deployed on both hub and spoke. You can deploy just a subset that you need based on the role of the cluster. And then, yep.
Okay, thank you.
Yes, Mario.
Yeah, so I think I have a question more about use cases. So when would it be preferred to use this solution compared to, for example, just scaling up the resources of the hub cluster and not sending anything to a surrogate, to a minion cluster, for example?
Yes. Okay. So there are sometimes you cannot, you've reached the capacity of the cluster. So you cannot scale the cluster indefinitely. Usually the first things that suffer are the API server and etcd. So it's not even a lack of nodes. So like there is compute power. You can scale the cluster to add more nodes, but you cannot scale etcd. Like there is at least an OpenShift, the 8 gigs limit, and the database is just getting full, and then that's it. Like you cannot add any more resources. So this is a case where you would like to run the workloads in another cluster. We also had like today I've seen a cluster that reached the maximum amount of nodes. So there were no more IP blocks for pods because there were 120 nodes in the cluster. That's it.
I see, makes sense. Thanks.
Yes, Adam. So
Maybe I just have a question. If etcd is one of the main limiting factors, do we plan to also either improve our etcd usage or replace etcd with, I don't know, what Google is doing?
we are trying to be as much efficient as we can utilizing etcd. One of the biggest changes was made by the build team, changing the method for mounting secrets to pods. It drastically reduced the size of pod definitions. The move to as it sounds like a small change, but the move to a shared runner and the build CLI that will take out the inline scripts from task runs. It sounds like not a lot, right? But imagine that you have thousands of those task runs in etcd. It piles up. So even reducing removing the inline code will help to improve the DB usage to optimize it. We are making sure that we are not overloading the cluster in terms of the number of namespaces, the number of tenants. And this is also something that we would recommend for upstream installations, to be aware, like the amount. There is an overhead when you add the namespaces for tenants. It doesn't. There is a certain overhead, and when you add more and more, the baseline, the base usage of etcd, even if you are not running any pipeline at rest, the secrets, config maps, all of those, it takes place from etcd in etcd. Now about what Google and AWS are doing. They call it ultra scale clusters. So it was because of AI ML workloads where you need huge clusters for do training, and because the nature of this workload, you don't want to scale them over clusters. You want, this from my understanding, you need to run them all in the same cluster. There are a lot of considerations of how do you schedule pods, on which hardware, on which rack, so to optimize the learning and the network traffic. So I think this is the reason why you need very, very large clusters. So they call it ultra clusters, and for those, they just extended or replaced etcd with some other services, databases. In OpenShift, there are still no plans to do it. But for Konflux, like, I don't see what, like, if someone wants to run an ultra scale cluster that has this spatial database that can scale to huge number of nodes and workloads, Konflux should be able to use it over there, right? I don't think it's a problem for us to solve. It's for cluster providers.
Like generally, I'd say, like, I agree with you. I'm more thinking like if we should step on the OpenShift next, that we have such workloads. I believe we are not the only one that will have such workloads. I especially can imagine that if we will start selling Konflux, we will encounter such workloads. So they should fix it somehow, or like basically figure out how to do it. Like, I also don't think that it's necessarily like Konflux job to figure out how to do this kind of stuff in OpenShift, but I think that maybe we can also like push them on that front, because I know that we do quite a lot to make sure that etcd like usage stays within certain bounds. It's just I think that maybe OpenShift should also maybe figure something better out if we are now regularly reaching the limits of etcd.
But for the current context of this meeting, not just like OpenShift, it's like any you can say like any cloud provider, like any cluster. So it depends on the hardware that the user brings and the infrastructure the user brings. Yeah. So, I have nothing to say about this topic.
I'm next in queue. I've got a follow-up question about results proxy server. It talks about logs. Will it also serve like task run resources from the spoke clusters so that like TKN, TR list on the hub cluster could know about the proxy server and then get you a nice list of all your task runs as if they were on the hub cluster when they're really not?
I think it does. I need to see I've sent the link. In the link that I've sent, there is the endpoints. I don't remember by heart.
I could have gone and researched this myself.
So yes, again, I will share the link again.
Yeah. I see pods, pipeline runs, and logs, but not task runs. But maybe that's a thing that could be. No, there's task runs. My bad. Yeah, task runs is there. Cool. So even if there's not concrete plans not to modify TKN, the CLI, to know about and talk to the proxy server, it seems like that's possible. So it's a thing we could pursue. That's something like a nice UX for. I was thinking about whose question was it? I think maybe Mikola's about the administrator experience. Can you easily figure out where task runs are? And that would be nice if TKN TR list just worked.
Yeah, for sure. That the intention is to make it as transparent as possible to the user. That it's one of the key designs principles. Yeah. Adam?
So I guess I got two comments. One is as I'm very much getting strong memories from, I guess it was 3 years ago when the past iteration of Konflux was we were doing stuff with KCP, and we got Tecton to work with KCP, and the architecture patterns are very, very, very similar. So if there's any comment I would add is that it's the multi-kueue feels more narrow, specific, and focused versus KCP, where we realized very quickly we were trying to eat the entire world, and even the project realized that they couldn't solve it. They needed to solve every problem, and that was not sustainable. The other question, and this might be something that could be answered just by reading the docs, is when it comes to the scheduler, does it understand the fundamentals around like node selectors? Is that something that kind of gets weighed in this model? Because like in the back of my mind, one of the challenges we have, in addition to the scale, is there's no single cloud provider that provides every single CPU architecture that some folks, particularly the Red Hatters here, are building. So that would be it's in my mind, this could be a solution to help, but I think then we would be queuing the task runs versus the pipeline runs. So I don't know if you know that answer offhand. If not, I'll certainly take it offline since I think we're calling time on this topic.
It can solve. So yes, it's another thing that it can solve if you need hardware that you don't have on your hub cluster and you can get only on the spoke. It can solve this problem, but at the pipeline run level, there are benefits of doing even on single cluster. There are a lot of benefits in doing the queuing at the pipeline run level, especially when you want to protect the cluster, not overloading it, and to not get into a situation where pipelines are timing out because lack of resources. So the pipeline starts. Let's say that you are queuing task runs. So pipeline starts, and then task runs get stuck in the queue, and then pipeline run can time out. So there are benefits in doing the queuing at the pipeline run level. This is why Tecton queue was built to handle the pipeline run and not the task runs. And in queue, it comes to queue. So queue has a concept of resource flavors. A resource flavor is an abstraction on top of node selectors, taints, and tolerations. You associate a resource flavor with a queue, and then when queue tries to schedule a workload, so in the queue definition, there is a list of flavors. It goes one flavor after the other until it finds the first one that has available resources, and this is the flavor that is getting that will be used. What does it mean? It means that the node labels, node selector, taints and tolerations that are defined in this resource flavors will be applied to the workload. Okay, and then it affects the hardware that is going to run the actual workload. So this is one way to let queue affect on which nodes the pipeline will run. And another way is just use different queues. So you can have multiple cluster queues and based on the type of the pipeline run or the type of hardware that it needs, just channel them to different queues. You can also send the documentation about it.
Looking at time, Gal, I think we got to wrap up. Thank you for this presentation. I think it was really informative for me and probably for everyone else too. Cool.
Sure.
Thank you so much. Yeah, next up on the agenda, Mikola is up. Mikola, you ready to go?
Yeah, thank you, Rob. So I would like to discuss a question regarding build pipelines. So let me explain briefly the problem I would like to talk about. So currently, and this is like historical reasons why we still have it, we support Dockerfile parameter in our build pipeline, and it could be both path in the local repo and URL to a resource somewhere. And currently we have both of them. So, however, having Dockerfile somewhere else and download it each build is way less secure because we don't have it in the source tarballs, which has hashes and everything. Yes, we are safe because of Conforma, so it would just gate such stuff unless you heavily disable all the policies. But anyway, in build team, we don't see much of a benefit of such functionality, but only like a security risk. So we plan to remove this ability completely. And if someone needs to test some Dockerfile or whatever, so it's quite easy to include it into a commit in a branch. And like we see no blockers in these directions. But I would like to ask community if there are any objections regarding this or concerns, any thoughts? Okay, thank you. If there is no objection, thank you. We will proceed then. Thank you.
Thank you for raising it, Mikola. Just a point of process, I'm thinking that on the call today, we have 22 people, but there are more than that in the Konflux community. A question like this, where you're searching for the one person who might have a reason to object, you might write a short email to the mailing list as like a catch a broader set. And but I can't anticipate there'd be any objection. Just
yeah, thank you.
Thank you. Barak, I see your hand.
Yeah, I'm just thinking like this is an architectural decision, so an ADR around this, like, it's also a great way to ask, right? We have all the process around ADR for, it doesn't need to be long, but kind of gives us the process for asking this kind of thing.
That makes sense. Andrew.
I mean, it is an architectural decision, but it's around the task. I don't think that it's something that we need to use an ADR for. I think trying to ask in the email, it seems like a reasonable step.
Yeah, I guess I'd add to that just that it's about like maybe just using our judgment. What's the likelihood that it's going to affect other teams and broader things? And it does seem fairly isolated. If the email thread raises more questions, then we could move into an ADR if we need to deliberate something about it. But my bet, it's just a bet, is that won't be necessary here. With that, thank you, Mikola. Real quick, I wanted to just do an FYI that FOSDEM is this weekend, and we have at least 2 different groups from the Konflux community presenting. I put the agenda for the SBOMs and supply chains dev room at FOSDEM on the sidebar. It's Stefano and Eric and Martin are going to be presenting. Those are the ones I know. If there's anybody else you know who's presenting at FOSDEM or is going to be at FOSDEM, maybe have them chime in a thread in upstream Slack so that everybody can find each other while they're there. Exciting. If any of those people are on the call today, I'm not sure. Maybe I'll follow up with them on Slack. I'd love to hear back next week from FOSDEM if they like learn anything interesting, get a trip report either to the mailing list or on the community call. Would be cool. That's it for that point. Barak, telemetry ADR. Gonna kick it off?
Yeah, thanks. So it's a little ADR. Talks about the topic of adding telemetry to the Konflux deliverable. It's a very early iteration of this, or right now it's basically about where do we put the keys and how do we collect data and how do we deliver it and how do we add the enable disable flags for this. And right now it is focused around sending telemetry to Red Hat. At some point, we'll probably have documentation for how to send telemetry to other places and to maybe even include ways to collect it yourself. But right now it's kind of, again, we're trying to not overscope what we're doing. So so basically it's kind of a basic mechanics for how do we want to do this. Please go ahead and have a look, and let's have the discussion there and make progress.
I have a comment on it real quick, Barak. Is the section about like declaring how many segment API keys we're going to have, and that we'll have one for each of these different use cases. Because it's an upstream ADR, I think it should be possible to refactor it to say that, like, you know, a provider who is running Konflux should be able to have at least these three kinds of categories of keys. One for, you know, an arbitrary use case, one for their own operations in a cluster, and yet another if they're distributing or redistributing Konflux to another. And it just takes the particular vendor, Red Hat, out of that equation of the ADR. Do you think that's possible?
Yeah. Well, I'll rethink this. Like, how do I, do this for a more upstream standpoint? Because again, you know, if you're vendoring Konflux or, you know, rebuilding Konflux, you can have as many kinds of keys as you want. So maybe the point is that we need to make sure there's a mechanism to override the keys in certain places in the supply chain. And, you know, my real point there was kind of trying to mention that there is going to be some key that it's shipped with, like vanilla Konflux from the upstream build, and that there is a dev key. Maybe I need to write. There is a dev key that's not going to be, you know, committed to the source or anything. But like, if you're a developer that wants to work on the telemetry, you can ask for it, and then you'll be able to see the data that gets sent into the stuff linked to that key.
That all seems reasonable to me, like framing for you know, any upstream contributor should be able to come and ask for that key to use it for testing and developing.
Yeah.
That makes sense.
Yeah, that's what I was trying to aim, but maybe I need to get the wording better around this.
Cool. Anyways, thank you. So we'll do, just process-wise, we'll do the 2-week call for comments period. I will async in the background, add the next milestone for that, so it gets queued up in that process. If nothing else on the telemetry ADR, Barak, do you want to move on to site analytics?
Hold on, just my browser jumped away from the tab for some reason. Let's start. So it's kind of like a similar topic where, just like we're doing analytics for the in telemetry gathering for the kind of Konflux package itself, we want to do something similar for the site. Just like any other group of people running a site, we want to know if we have page views and button clicks and things like that, and to do the kind of things people do to optimize site engagement. So we need to gather some analytics for this. And I've been struggling with the legal aspects of how to do this for the last few weeks. Ultimately, because most of us are Reddit employees, and Reddit is going to be paying for the domain and the hosting and whatever. So the instructions from Red Hat Legal is to also kind of let Red Hat be responsible for the privacy policy, which means we're essentially going to link to the Red Hat privacy policy. And for every kind of you know, legal process where somebody wants their data deleted or to retrieve their data, there is a team at Red Hat that's taking care of it for everything at Red Hat, and it will be their job to take care of it for us as well. They will just need to know how to come to us and ask us to delete the data that we've collected or deliver it or whatever it is they need to do. So basically, it's kind of an inversion of what I was trying to do so far, which was to kind of have us handle everything. But so instead of that, Red Hat is handling most things, and we are handling smaller aspects of this entire question. So basically, there are going to be PRs being uploaded to the site code over the next few weeks with adding, you know, the cookie consent forms and telemetry and stuff like that. You will see that.
Well, that sounds good to me. Any questions or concerns about that?
Like, even though it would probably be the best if we have our own privacy policy, I think this is also like great solution for now. Maybe when Konflux community is bigger, then we should reconsider. But thank you, Barak, for like following through on this. Like, I was once in such conversations, and I know they are not like not the best, not the greatest, especially for engineers.
Yeah, ultimately, by the way, if you want to know, ultimately the argument from the Reddit legal point of view is that they cannot maintain policy for every single community site that Reddit is involved with. So as long as Reddit is paying, they want their policy to be used.
Cool, that makes sense. Okay, thank you, Barak. And that gets us to the end of the agenda. Thank you, everybody, for attending today. Good discussion. I'll end the recording and we'll put this up on YouTube later.